Okay, let's get started. These videos are going to be the solutions worked out for the problems posted in the review slides for exam 3, so that you guys have somewhat of an answer key for these problems that are relating to material from chapters 7, 8, and 9. So let's get started with this first one. It says the process of boiling a liquid has a, and then there's all these different answer choices. Before I even read the answer choices, I'm going to write down here a reaction, just a generic reaction for the process of boiling a liquid. So on the reactant side, we'll have some substance. We'll call it substance A, and it's a liquid. And as we boil, we are adding heat, and we are turning it into a gas, okay? So what this means is that heat is a reactant here, because you cannot boil a liquid unless you add heat to that liquid. So if heat is a reactant, then we have an endothermic process on our hands, which means delta H, enthalpy, is positive, okay? So if you start reading the answer choices, we're going to cross out anything that says enthalpy is negative, because for this reaction, enthalpy is not negative, it's positive, and we do have enough information, so it's not going to be E. So it's either going to be A or B, positive enthalpy change. So now we need to consider what entropy is doing. We are going from a liquid to a gas. So we have 0 moles of gas on the reactant side. We have 1 mole of gas on the product side. And gas is the most disordered state of matter. So delta S here is also increasing. Disorder is increasing. As you go from a solid to a liquid to gas, disorder increases. So we need to select the answer that says positive enthalpy change and positive entropy change, which is A. Okay? So that is the first problem. Let's move on to the second problem. It says predict the sign of delta S, positive or negative, for the following reactions. Okay, remember delta S is a measure of disorder. Okay, this is enthalpy. So what we're doing is we're taking into account the states of matter, which you notice on all of these reactions, 1, 2, and 3, we have the state of matter listed for all reactants and products. So I need some space to write, so I'm going to erase this. I'm just going to go through on this first one. We have 2 moles of a solid, and we have 1 mole of gas. And then on the reactant side, we have 0 moles of gas, and we have 2 moles of a solid. Okay, so 2 moles of solid does not change, but what does change is that we have go from 1 mole of gas on the reactant side to 0 moles of gas on the product side. So disorder here is decreasing. We're becoming more ordered, because we go from 1 mole of gas to 0 moles of gas, so delta S is negative. Disorder is decreasing. Order is increasing. Is decreasing. Okay. Number 2, we have 1 mole of a solid, C6H12O6. Maybe you recognize that. That's glucose. On the product side, we have 2 moles of liquid, and we have 2 moles of gas. So essentially we're going from a solid and we're making liquid plus gas. These states of matter, liquid and gas, are way more disordered. The molecules can move about more freely, have more energy, so disorder is increasing here. So delta S would be positive. Disorder is increasing here. Lastly, if we look at this number 3, we have 2 moles of gas, and then we, plus another mole of gas. So we actually total have 3 moles of gas total. On the product side, we have 0 moles of gas. We have all liquids and aqueous substances. So as you go from a gas to a liquid, you're becoming more ordered. It's only in a gas state of matter that the molecules have the highest amount of disorder. Liquids and solids are more ordered. So here, delta S, which is a measure of disorder, is decreasing. Okay, so order is increasing, disorder is decreasing. All right. Next question. Which combination of delta H and delta S for a reaction is not spontaneous at low temperatures and becomes spontaneous at higher temperatures? So real quick, before I even begin to analyze this problem, if something is not spontaneous, that means the delta G has a positive value. We have a positive delta G. Okay, and then if it becomes spontaneous, that means the delta G becomes negative. Okay, if you remember, we worked a problem in lecture about ice melting. We had 3 different temperatures. That's kind of very similar to this. We solved for delta G with 3 different temperatures for the process of ice melting. And what we saw in that particular problem was that we started out with a positive delta G, and then it became a negative delta G. And so, first off, I'm going to kind of make a table over here. I would definitely put a table like this on your note card. We will still do a note card for exam 3. If we have a negative delta H and a positive delta S, we will always get a negative delta G. On the flip side, if we have a positive delta H and a negative delta S, we will always get a positive delta G, okay? And remember, negative delta G is spontaneous, positive delta G is not spontaneous. So it's neither one. The combination that it's asking for is neither one of the 2 we just listed, row 1 or row 2. It's neither one, because we know the sign on delta G and it doesn't change. It doesn't start out as 1 and become something else at different temperatures. Okay, if you have a row 1 and 2 here, if you have these signs on your delta H and delta S, the sign of delta G will not change. So it's neither one of these combinations. What it must be then is either a positive positive or a negative negative. So let's consider, we'll call this row 3 and row 4. Okay, so let's consider row 3. And remember, I'm going to write out the equation for delta G. Delta G equals delta H minus T delta S. And you'll remember, I like to put brackets around T delta S. Before we begin, remember that delta H values are usually a lot bigger than delta S values. How do we know that? Delta H is measured in units of kcal or kJ, kilojoules. Okay, these are the units for delta H. And delta S is usually measured in values of calories or joules, okay, which are way smaller by 1,000. So we usually have larger values of delta H, smaller values of delta S. So what I'm going to do here is just plug in some random numbers that I literally make up, and I'm going to see what our delta G comes out to be. I'm just going to plug in arbitrary numbers, but I'm going to make my delta H bigger since it's normally way bigger than delta S. So for example, let's plug in 10 for delta H. Don't worry with units right now. We're just looking at what happens when we change temperature. First, for temperature, I'm just going to plug in a 1. You can never have a negative temperature, so I'm going to plug in a positive 1. And let's say my delta S is 2. Okay, that's a lot smaller than 10. So let's do the math here. 10 minus 1 times 2, which is 2, gives us positive 8. So here, this is our low temperature scenario, because the problem says when it starts out at low temperatures first off. So now let's do a high temperature scenario. And let's see what happens. I'm not going to change my numbers. We're solving for delta G. I'm not going to change my numbers of delta H and delta S, that is. So I'm going to plug in 10 for delta H. Let's crank up the temperature though. Let's make it 20. That's a high temperature compared to 1. I'm not going to change my delta S, which should be a 2, not an S. So plug in 2 again. Now let's do the math and see what our delta G is, what the sign on it is. 10 minus, and then 20 times 2 is, this is 40, okay? And remember there's a minus sign here. So 10 minus 40 gives us negative 30, okay? So what we see is at low temperatures we have a positive delta G, which again is not spontaneous. And at high temperatures we have a negative delta G, which is spontaneous. So a positive delta H and a positive delta S, this is the combination, okay? Positive and positive gives a scenario where at low temperatures we have a positive delta G, and at high temperatures we end up with a negative delta G. Okay, so that's the answer to this question. The combination it's looking for is a positive delta H and a positive delta S. We don't even have to play out scenario row 4, okay? We don't have to play that out. All right, let's move on to the next question.